So I'm going to record on how to do this problem because it is actually incredibly, well, at least for me, it was one of the most difficult problems of this section, which requires you to know how to use the double angle identity formula and half angle identity formula to solve the problem. It's fucking crazy. So this is one of like the crazy cases, the even case. Usually it's not that crazy, but when we have a bigger number here, it gets pretty crazy. So to start off this problem, we want to rewrite it as sine 2t cosine 2t cosine 2t. And you'll see why in a second. So the solution manual goes over another method on how to do this. It was very fucking complicated. So, I watched a Professor Leonard video and I just figured out that you could do it this method as well. You can then do sine 2t cosine 2t together, cosine 2t. From here we can take out this is the same, we can rewrite it as sine t cosine t squared. This is the exact same as that, right? Now let's not forget the cosine 2t. So from here we can use the double angle identity there. So if we simply divide by 2 from both sides, those 2 cancels and it would give you sine cos is equal to sine 2t over 2, which we can replace over here. I'm not going to write it over 2, I'm going to write it as 1/2. 1/2 sine 2t squared cosine 2t. So here we're actually, because it's a constant, we're going to put the 1/2 outside and we're going to just keep with sine. Well, it actually is 1/4, my bad. It's 1/4 because we square both of these, because this would be sine squared 2t. So don't forget to square that one. I almost did. So you square it and then you take out the constant, which would be 1/4, and it would leave you with this. Afterwards, we want to use the half angle identities here. So the sine and cosine are basically the same, but once you solve for cosine t and sine t, you are actually going to get cosine squared t is the same as 1 plus cosine 2t. So what's crazy about that one, and I almost forgot 1/2. What's crazy about that one is we can use them for both scenarios, except in this scenario it would be 4. So it would be sine 2, it would be a 1 minus cosine. Well, let's first do this. 1 minus cosine 2 4t 1/2, and then the cosine 2t would be the 1 plus cosine 2t. I'm almost forgetting the 1/2, but that multiplies, that becomes a 4. 1/2 and 1/2, that's 1/4. And we can actually multiply the 1/4, get the constant outside the integral, which would be 1/16. So we would now just FOIL this, which would give us 1 plus cosine 2t minus cosine 4t minus cosine 4t cosine 2t. Now if we do the antiderivative of this whole thing, it would actually give us 1 plus sine 2t minus sine 4t, because remember we're trying to get cosine for the antiderivative, so it would be minus sine 4t cosine 2t. And what's crazy about this one is when we do from 0 to pi, 0 will just be 0. Oh, I almost forgot the t here. The 1 becomes a t. When we put pi in here, we put pi, remember that sine of 2 pi is always going to be 0. 4 pi, doesn't matter, it's also going to be 0. This one, oh, I almost forgot the sign here. This one's also going to be 0 and 0. So the answer, the final answer would be pi over 16.